Today we're going to be looking at how to solve one-step multiplication equations with negatives. We have a couple of examples that we're going to work through together here, so let's get started. For question number 1, we're being asked to solve for the value of r in the problem negative 12r equals negative 48. And in order for us to isolate our variable of r in this problem, as we can see up top highlighted in yellow, we're going to need to perform the inverse or the opposite operation of whatever is being done to our variable in question number 1. And here we have negative 12r, and since there's no operation between our number and our variable, it tells us that we're going to be multiplying. And the inverse operation of multiplication is division, so on the left-hand side of this problem, we're going to be dividing it by negative 12. And this brings up a very important point here in that we need to keep both sides equal, as we can see highlighted in blue up top. So that means that since we're dividing the left-hand side of this equation by negative 12, we need to do the same thing to the right side of this equation as well. So starting out with the left-hand side, well, our multiplying negative 12 and dividing negative 12 cancel each other out. So now our variable of r is isolated, and then when we divide negative 48 by negative 12, since we're dividing a negative by a negative, we're going to get a positive quotient. So when we divide negative 48 by negative 12, we get 4, so r is equal to 4. And if we want to double check this, just to make sure that we have the correct answer here, we're going to plug in our value for r in our original problem. So we have negative 12 times 4 equals negative 48. And now here, since we're multiplying a negative by a positive, we're going to get a negative product. So when we multiply negative 12 by 4, we get negative 48. And then since both sides of this equation are equal, it means that we have the correct answer. R is equal to 4. Now moving on to question number 2, where this time we're being asked to solve for the value of n in the problem negative 6n equals 54. So just like with the first problem, in order for us to isolate our variable of n, we need to perform the inverse operation of whatever's being done to our variable. And here, since we have a number that's directly beside our variable with no operation between them, it tells us that we're multiplying, and the inverse operation of multiplication is division. So on the left-hand side of this problem, we're going to be dividing it by negative 6, and then we need to keep both sides equal, so we're going to do the same thing to the right side of our equation as well. Starting out with the left-hand side, multiplying by negative 6 and dividing by negative 6 cancel each other out, so now our variable of n is isolated. And then for the right-hand side here, we're dividing 54 by negative 6, and since we're dividing a positive by a negative, we're going to get a negative quotient. So when we divide 54 by negative 6, we're going to get negative 9, so n is equal to negative 9. And just to make sure that we have the correct answer here, we're going to plug in our value for n in our original equation. So we have negative 6 times negative 9 equals 54. And when we multiply negative 6 by negative 9, since we're multiplying two negatives, it means we're going to get a positive product. So when we multiply negative 6 by negative 9, we get 54. And then since both sides of this equation are equal, it means that we have the correct answer. N is equal to negative 9. And if you're unsure of why it is some of our answers are negative and some of our answers are positive when we're working with negative numbers, I encourage you to pause the video and take a look at some of the video links in the description below, where we go over multiplying and dividing both positive and negative integers in a lot more detail. So hopefully by now you understand how to solve one-step multiplication equations with negatives. Help make math less complicated by smashing those like and subscribe buttons. As always, enjoy today's math journey.